All right, geometry kids. Hope you're doing well and you had fun doing the tangent ratio. We got two more, the sine and the cosine ratios. These are the buttons on your calculator that say sin and cos. So on your calculator, we're using this one and this one. Okay, so sine, cosine, and then we had the tangent one from the last time. So we get to use those buttons today. There are also ratios. Ratios just like tangent, they're just ratios of different sides. Again, you have to have a right triangle to use these the way we're using them right now. Later we'll cover a law of sines, law of cosines, where they don't have to be right triangles. That can be kind of fun. But again, you have to have a right triangle. This is page 262, 9-5. And the sine is the opposite over the hypotenuse. So here comes the hypotenuse. We did not use that for tangent. So sine, if you have angle A, sine is the opposite over the hypotenuse. So that is abbreviated so. Sine is opposite over hypotenuse. The cosine, so if I still have angle A, the cosine is not the opposite. It's going to be the adjacent over the hypotenuse. So both sine and cosine use adjacent. So cosine is ca. So you have sine is opposite over hypotenuse, ca. Cosine is adjacent over hypotenuse, and then we had TOA from the other lesson. Tangent is opposite over adjacent. So the saying a lot of times is SOHCAHTOA, and it makes more fun if you say it with an accent like SOHCAHTOA, or SOHCAHTOA, or SOHCAHTOA, or SOHCAHTOA. You can come up with your own fun accent and say it. Okay, record it and send it to me, please. Oh, that'll be good. So these ratios are what we're using. It's going to be a very similar assignment, but now instead of just having tangent all the time, we'll have to determine are we using sine or cosine. Eventually we'll pull in that tangent as well. Okay. So here it is. You can write your definitions for sine and cosine: opposite over hypotenuse, adjacent over hypotenuse. Get those memorized. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. The angle of depression is going to be new. That is this angle up here. Angle of depression is kind of like how much are you looking down. I hope you're not depressed right now. Keep your eyes up. Have an angle of elevation. That was this one down here, angle of elevation. If you're down here looking up, or you're top on a cliff, you're looking down inside a canyon or something like that, that would be an angle of depression. So an angle of depression starts high, looks down. Angle of elevation starts low and looks up. So depression is going down, elevation is going up. So opposite over hypotenuse. So sine is opposite over hypotenuse. We say sine is opposite over hypotenuse. There's a so. Screw that up, sorry about that. Normally kids are here looking at this on the board, and you can tell me when to scoot that up. SOHCA, cosine is the adjacent side, the wide side next to, over the hypotenuse. So cosine is adjacent over hypotenuse. TOA. Tangent is the opposite over the adjacent side. Tangent is opposite over adjacent. Okay, so SOHCAHTOA. Here we go. Next thing, we're clicking right along. Okay, sine and cosine of complementary angles. There we go. Sine and cosine of complementary angles. The co of sine stands for the word complementary, and it's the sine of the angle's complement. Okay, so the cosine of B is going to be the same as the sine of the angle's complement. So when you see this right here, they are talking about complementary angles. Angles. Who wrote angles? Angles. Okay? So complementary angles, 90 minus A is B. So how it works is if you have the sine of 80 degrees, that would equal the cosine of 90 minus 80. Well, its complement has to be 10, so that's the cosine of 10 degrees. So the sine of 80 would equal the sine of its complement, which is 10, the cosine of 10. So sine of 80 would be the cosine of 10. If you have the sine of 60, that would be the cosine of 90 minus 60, which is 30. It works both ways. Cosine of 20 would be the sine of 90 minus 20, which is 70. Those would be the same. So your questions, make sure I have the right ones here. Yep. Okay, a lot of those examples right here. So they want to find the sine of f, the sine of g, the cosine of f, and the cosine of g. Write each answer as a fraction and as a decimal rounded to 4 decimal places. So the sine of f. Here's f. Sine is opposite over hypotenuse. So this is our hypotenuse. That's going to be hypotenuse for everything. Opposite f would be 12 over 13. Okay, so 12 over 13, you actually don't need it as a decimal on the assignment, so I'm not going to do that. You can do 12 divided by 13, get your decimal if you want to. Okay, but it does have to be in simplest form. So sine of f is 12 over 13. Cosine of f would be the adjacent side over the hypotenuse. So here's f, the adjacent side is 5, so 5 over 13. And now remember, f and g will be complementary, so you're going to see some patterns forming in here. Because that's 90, f and g have to be complementary. So if I take sine of g, there's g up top. Sine is opposite over hypotenuse, so that would be 5 over 13. And the cosine of g would be adjacent over hypotenuse. So that's 12 over 13. So you notice the sine of f and the cosine of g are the same values because g and f are complements. So the sine and cosine of those are going to be the same. Okay, try 2, try 3. We'll get there. Pause it if you need to. Try it on your own. Write these down. Okay, Ben? Write them down. Practice writing it. Sine of f. Opposite over hypotenuse. This is my hypotenuse. Make sure the longest side is the hypotenuse. The sine of f would be 65 over 97. Does that reduce? You need to check to see if that reduces. 97, I don't think that would. Some of you probably already know it. Nope. The sine of f equals 65 over 97. Cosine of f would be 72 over 97. That stays the same. So the sine of g should be 72 over 97. There's g opposite over hypotenuse, 72 over 97. The cosine of g should be 65 over 97. So g adjacent would be 65. That'd be hypotenuse. If it helps, hold your paper or turn your screen at an angle that helps you. And it helps me to put that right angle in a corner like that. Okay, so the sine of f, here's f, opposite over hypotenuse, so that's root 2 over 2. Notice they're the same. So the cosine of f would also be root 2 over 2. The sine of g, opposite over hypotenuse, would be root 2 over 2. Cosine of g is the same thing, root 2 over 2. There's g, adjacent is root 2 over hypotenuse. There's your hypotenuse. Okay, if these are the same, what kind of triangle do you have? It'd be an isosceles triangle, isosceles right triangle, that's a 45, 45, 90. So the hypotenuse is root 2 times as long as the leg. So if the leg is root 2, if you take it there, you take it times the square root of 2, root 2 times root 2 is 2. That's a 45, 45, 90 triangle right there. 4 through 6, write the expression in terms of cosine. So the sine of 9, this is where we're using this formula up here. So the sine of 9 would be the cosine of 90 minus 9, which would be the cosine of 81. That's the cosine of 90 minus 9, so cosine of 81 degrees. Sine of 60, so we take 90 minus 30, sorry, there's 60, you get 60. So it's the cosine of 60 degrees. 90 minus 77 is 13, so that's the cosine of 13 degrees. So all you're doing on those, take 90 minus the angle. Write the expression in terms of sine. So same thing, 90 minus 15 is 75, so that'd be the sine of 75 degrees. You can use your calculator and check it out. Cosine of 15, ooh, we don't need that fanciness, there we go. 0.9659, and the sine of 75, 0.9659. So cosine of 83, 90 minus 83 is 7, so that is the sine of 7. 45, 90 minus 45 is 45. It's the sine of 45. So sine and cosine of 45 degrees. That's why you got the 45, 45, 90 triangle on the other side. Okay, now the fun ones. Find the value of each variable using sine and cosine. Round your answer to the nearest tenth. So we need to find the x and the y. That's what they're looking for. First of all, this label, what is it? Is it the adjacent, the opposite, or a hypotenuse? So I have a 9. I see that it's opposite the 90-degree angle, so that it makes it the hypotenuse. So if I want to find, let's do the x first. Here's my angle. That makes the x the opposite side, and the y is the adjacent side. So which trig, here's the key question, which trig, if I'm looking for x, which trig ratio uses the opposite and the hypotenuse? Okay, and that's kind of the key part to this, is figuring out, do I need to use sine, when do I use sine, when do I use cosine? And you have to look at the labels on the triangle and be like, okay, I want to know the opposite side, I know the hypotenuse side, this is my given, I know that. So opposite over hypotenuse, you look at your trig ratio, SOHCAHTOA. Where did the other page go? There it is. That's what I'm looking for. SOHCAHTOA, and you see, okay, sine uses opposite over hypotenuse. We're going to create an equation just like what we did with tangent. So for the x, I have the sine of 16 degrees equals the opposite side, which is x, over the hypotenuse, which is 9. So sine of 16 is opposite over hypotenuse, so x is going to equal 9 times the sine of 16. Okay, so 9 times the sine of 16, we get about 2.48, round your answer to the nearest tenth, so that's about 2.5. So I'm using sine because it's opposite over hypotenuse. In 15 minutes here, we'll go over again. Okay, so sine of 16 is opposite x over hypotenuse 9. Solve for x. X is on top, so it's 9 times the sine of 16. So the y is the adjacent. So I'm looking for the adjacent. I have the hypotenuse, so which one uses adjacent and hypotenuse? I'm like, well, that's the cosine is adjacent and hypotenuse, adjacent over hypotenuse. So I get the cosine of 16 equals the adjacent side, which is y, over the hypotenuse, which is 9. So y equals 9 times the cosine of 16. 9 cosine 16. And we get 8.7. Okay, so that would be the other two sides of those lengths. Lengths of those sides. Done quite a few videos today already, so I'm getting towards the tail end of the day. Okay, so again, here's my 72, the 50. It is opposite the 90, so that is my hypotenuse. You may want to try this one on your own before you get to it, because it's going to change a little bit on 12 and 13. So if I'm looking for M is next to, it's forming the angle. That is the adjacent side. This is the opposite side. So if I'm looking for M, I have to use cosine. Cosine of 72 equals adjacent over hypotenuse. So M over 50. So M is the 50 times the cosine of 72, which is 15.5. Okay. Try the n. Pause it. Go try it. N is opposite over hypotenuse. There's a 72. That's opposite. So the sine of 72 equals n over 50. So n equals the 50 times the sine of 72. And 47.6. Okay. C and D. Okay, so here's the 47. This is the hypotenuse. This is opposite. And this is adjacent. So let's find the hypotenuse first. It doesn't matter whichever one you want to find first. I know my adjacent. So adjacent and hypotenuse is cosine. So the cosine of 47 equals 10 over d. Now the variable's in the bottom. So we go d equals 10 over the cosine of 47. When the variable's in the bottom, you take the other length divided by that trig ratio. You have 14.7. And C. Now, always go back to, even though we know the hypotenuse now, always go back to your given, because that's not a rounded answer. 14.7 is a rounded answer. You're going to get far enough off, it may not count it. So if I have the adjacent, and I want the opposite and adjacent, that relationship is tangent. So the tangent of 47 is opposite C over adjacent 10. So in order to find C, would you take 10 times the tangent of 47? Or 10 divided by the tangent of 47? Well, you'd have to multiply the 10 over. So C is 10 times the tangent of 47. So 10 times the tangent of 47. About 10.7. Okay. So go try 13. I'll work that one out, then we'll look at the word problems. Hey.
No recording?
Oh no, we're going right now. I'm just writing an example. You got a guest speaker in here.
Oh yeah.
No, you got to come around.
Yeah.
Document camera.
Hey guys, learn math.
Yeah.
Good for you.
All
right. Was
yeah.
it algebra 2 or
no, this is geometry.
Oh, fun.
Yep.
Okay. I don't need any more of that.
You don't need more.
I'm heading home.
All right. Have a good day. Okay. So B was 30.9, and A again tangent. The tangent of 65 equals 28 over A. So A is 28 divided by the tangent of 65. 13.1. Okay, sorry, this one's getting long. Camera attached to a kite. So a person is standing 100 feet away from the center of the closed-off area. So here you are. Woohoo! And here's the center, and that's 100 feet. The angle of depression from the camera to the person flying from the camera, okay, angle of depression from the camera is 25 degrees. So that's this one up here, 25 degrees. How long is this string on the kite? So this is your kite up here. They want to know x. So they want to know the hypotenuse. And the part that we know is the opposite. Now keep in mind you could find this angle down here and then use cosine. Okay, this is not drawn to scale because obviously that is not 25 degrees. So opposite and hypotenuse, that would be sine, opposite over hypotenuse, so the sine of 25 opposite 100 over hypotenuse. So x is 100 divided by the sine of 25, 236.6. Make sure you're doing this yourself also. That's how much string we have on this kite. If the string on the kite is 200 feet long, how far away must the person flying the kite stand from the center of the closed-off area, assuming the same? So, same thing. Sine of 25 equals opposite over hypotenuse, so it would be x over 200 this time. So x equals 200 times the sine of 25, which is 84.5. Okay. Good work. Go take a break, run around the house a little bit, and then come back and get started on your practice stuff. A lot of it is what you have up here. Okay. Good luck. Let me know what questions you have. Send me pictures if you have anything major. And I'll see you soon.